triangles and the law of sines. Those of you who come through the Cambridge program, you have been introduced already to law of sines and cosines, so this should be a fairly easy chapter for you. We are skipping chapters 5 and 6 right now. What we're going to do is cover chapter 7, and then the rest of the semester we will spend on chapter 5 and 6 and do as much of those two chapters as we can. So the objective for 7.1, you're going to apply the law of sines to solve a triangle that does not have a right angle, otherwise an oblique triangle. And you're going to calculate the area of an oblique triangle using the law of sines. So when finding the missing side of an angle or a right triangle, we use the rules. These are the rules when we have a right triangle, but what if we don't have a right triangle? How are we going to be able to solve it from that? So this one here, I know it says please take a moment to put on a note card, but these are already on those reference sheets that I gave you, the cardstock. It's off-white, yellow, whatever you color. So it's already on there. So you don't really need to go and add this to a note card when you have it on something else, unless you want to. So an oblique triangle is a triangle that is not a right triangle. To find the missing side of an angle of an oblique triangle, we can use the law of sines. So in any triangle ABC with sides A, B, and C, A over sine of A equals B over sine of B, which must at the same time equal C over sine of C. This is if we're looking for a side. If you're looking for an angle, you're just going to flip it over. This is on the cards. You're going to flip it over. So anyways, it would be, so this is if you're looking for a side. Okay, so anyways, this is if you're looking for a side. If you're looking for an angle, you'll just flip it over. Sine of A over little a, must at the same time equal sine of B over little b, and so forth. Now this is only to make the algebra easier when you're going through doing the math. That's the only purpose on those. So in our first example, to use the law of sines, we simply need to use 2 of the 3 fractions and fill in 3 of the 4 missing parts. So on this one here, this one, don't use a calculator because they're giving you actually really nice values. Find the side of A. They only ask you to find A. So on this one here, we're going, okay, well, I have A. I have angle A. I have this side, but I don't have the angle. And I have this angle, but I don't have this side. This one is always going to be a question mark for now. But I can come up with this angle because the 3 angles in a triangle still have to add up to 180. So if we add these up, we get 150 and subtract that from 180. This angle here is 30 degrees. So if I call this side C, angle A, and this would end up being little c. So using 2 of the 3 fractions, I have little a over angle A, so sine of A, would equal little c over sine of angle C. Fill in the 3 parts of the information you know. So A over sine of 45 equals 10 over sine of 30. Cross multiply. And we get, actually, don't even cross multiply. Take that back. I'm going to do take back on that one because you're causing yourself additional work doing that way. Just simply multiply both sides by sine of 45. So we have little a equals 10 times the sine of 45 over sine of 30. Now they told you not to use a calculator because this is unit circle angles. So this is going to be 10 times sine of 45, which is radical 2 over 2, over, and then the sine of 30 is 1/2. So on the top, I'm going to go ahead and reduce this down. The 10 and the 2 will cancel out, so you're left with 5 square root of 2 over 1/2. Multiply top and bottom by 1/2. I'm sorry, 2 over 1 multiplied by reciprocal. And we get 10 square root of 2. There's what your A equals. And you can always throw this into a calculator, double check your answer, that you get 10 square root of 2. Okay, so let's go to another example. Okay, second example here, determine the remaining sides and angles of a triangle. So you guys are going to get these nice little flashbacks from chapter, I think it was 2. Angle A equals, we don't know. Angle B is 52 degrees. Angle C is 29 degrees. Little a, and remember it's still the same thing. This is going to be little a. This down here is little c, and this guy is little b. Little a is 43 centimeters. Little b, we don't know. And little c, we don't know. Remember, you're always using 2 of the 3 parts, and you on law of sines, you have to have at least this, whatever side you have to have the angle as well. Now, angle A is missing, but again, as in before, add these 2 up. 9 plus 2 is 11. 5 plus the 1, carry the 1. 6, 7, 8, so this is 81. And we subtract that from 180, and we get 99 degrees. So angle A is 99 degrees. Now that I have angle A, always use, I'm going to write this in here, always use given information. Just as before, if you find side B and made a mistake finding side B, and then you use this guy to find C, you will get a mistake. So on this one here, I'm going to find angle side B, and then I'm going to find side C. So this is going to be little b over sine of B, which is 52 degrees, equals little a, which is 43, over sine of angle A, which is 99 degrees. Now you are going to have a calculator on this one, so make sure your calculator is in degree mode when you're working these through. Okay, so if I clean this up a little bit, basically multiply both sides by sine of 52. So these cancel out, and we're left with B equals this mess. When you throw this in the calculator, again, make sure you're in degree mode. Make sure you close the parentheses on the 52. So I'm going to get B is equal to, on this one after we throw it into the calculator, 34.3. Okay, so this is going to be 34.3 centimeters. And then we do the same thing for C. Little c over sine of C, which is 29, equals our A value of 43 over sine of 99. I also point out too, only thing that changed was what you're looking for. Multiply both sides by sine of 29. And then throw it into your calculator. Throw it into your calculator, and you get an answer of 21.1 centimeters. And this is where I get to remind you that the larger the angle, the larger the side, the smaller the angle, the smaller the side. So C is the smallest angle, should have the smallest side. A is the largest angle, should have the largest side. And they do, so we know we're good. Okay, this is exactly the same kind of stuff that we were doing before, only before you had to go, do I use tangent, do I use sine, do I use cosine? These are all law of sines. All of these problems are going to be law of sines. So that might make it a little bit easier. Okay, let's try another example. Okay, so number 10, determine the remaining sides and angles of each triangle. So we're going through the same thing. Angle A, they didn't tell us. Angle B is 69.38 degrees. Angle C is 74.08 degrees. Little a, they didn't tell us what it is. Little b, they didn't tell us what it is. And little c, they gave us is 45.38 millimeters. There's our given information. We will use C on both of the problems. Start with the easy one, finding angle A. So it's going to be 180 minus 69.38 minus 74.08. And we're going to get angle A to be 36 degrees, 36.54 degrees, once we do this math. And now we're ready to work through angle side A and side B. So I'm going to start with side A. Little a over sine of A on 36.54 equals little c, or 45.38 over sine of C. Oops. But we know what C is, so let's write it in there. 74.08. Multiply both sides by sine of 36. These cancel out, and we're left with A equals all of this. We throw that into the calculator, and A comes out to be 28.10. And don't forget the meters. And then we do the same thing for B. And keep in mind, this part is the only part that's going to be changing. Little b over sine of 69.38 equals 45.38 over sine of 74.08. Multiply both sides by sine of 69.38. These cancel out, and you're left with just B. Plug that into the calculator, and we get B to equal 44.17. And we do the double check again. We look at this, going, my smallest side is here. That's the smallest angle, smallest side, largest angle, definitely the largest side. Not surprising that these two are close, because they're close here as well. Okay, I think that what I'm going to do, even though this is only a 15-minute video, is I'm going to stop here, because the next one starts with two sides and one angle and having to find them out. So this will give you, we got through problem 10, so you'll be able to start on a good portion of the homework, even with this.